So calcium, I'm not going to get into too much detail on all of these, but calcium is a very important macronutrient element. Plants need a lot of it, but it's generally something that's readily available. Usually calcium is not added as a nutrient, it's added as a soil amendment. It helps with the soil structure, the soil tilth. It helps with adjusting pH, not the calcium itself, but something that's with the calcium. So you might have calcium oxide, which is a type of liming material, or dolomitic lime is a calcium magnesium carbonate material, limestone, another calcium carbonate material. And so calcium is not a liming material itself, but it is often in liming materials used to adjust the pH up. A lot of calcium is needed for strong cell walls. So if you're going to have a healthy plant that is good at protecting itself, being resistant to diseases, resistant to damage, hardy for the winter, you need plenty of calcium. If you have way too much calcium, it can actually get in the way of the passive process of absorbing other nutrients like potassium and magnesium. So you can't overdo the calcium too much. It's not toxic directly, but it interferes, it gets in the way of the plant passively absorbing the other nutrients that it needs. And I've already talked about disease resistance, possibly some pest resistance. The next one is magnesium. It is crucial in chlorophyll. It's kind of the equivalent to our iron in our blood. We need iron in our blood to make hemoglobin. It's the central molecule. Well, for chlorophyll, magnesium is that key central nutrient element that's needed to make chlorophyll. It certainly can fulfill some of the roles of calcium, but it is not a replacement for calcium. If you don't have enough magnesium, you get chlorosis, clearly because you don't have one of the building blocks to make chlorophyll. And you can start getting another stress response where the veins go red if you have a red variety. Because of the pattern of magnesium deficiency, it might look like a viral infection, and so you need to do some testing to verify. But that's true of most nutrient deficiencies. There's some other nutrient deficiency that might cause the same symptoms, or a possible virus that can cause similar symptoms. And so it's not obvious to look at a vine, look at the leaves, look at the situation and say, I know what's going on. Now, on your own vineyard with experience, you know exactly where the plants came from. You might have all of this other information in your brain where you know what's going on, and you can make the diagnosis just on the spot looking at it. But that's only because you've got history with your block, you have history with those vines, you know your soil, you can make those kinds of diagnoses because of that familiarity. If you're talking about some random leaves that came from somebody, if somebody just walked up to you and said, hey, here's some leaves from my vineyard, what's going on? There aren't too many people that I would trust that could make a good diagnosis. There probably aren't any that could make a good diagnosis without having the specific vineyard knowledge and experience to rule out other possibilities, because so many nutrient deficiencies and possibly diseases look similar enough, they're hard to tell apart without testing or lots of experience. Deficiencies are uncommon. When you do get them, they tend to be where you might expect it, in very sandy soils. You can have a problem if you overdo the potassium. Again, you overdo one of these macronutrients and you can interfere with the uptake of the others. Too much calcium interferes with potassium and magnesium. Too much potassium can also get in the way of magnesium. Poor choice of rootstock. can cause a deficiency. It's just the wrong rootstock for your region. Young vines are more susceptible, and that's generally because of magnesium content in the topsoil. As they get a larger root system and a more extensive root system through the soil profile, that tends to reduce those problems. Bigger problem in the coastal vineyards due to some serpentine soils. And we have some of those areas, like in Hollister, for example. I'm not sure where it would occur in our valley, but serpentine is a type of rock, a magnesium-containing rock, and very common in some areas of Hollister. Too much magnesium, and the soil, when it gets moist, is almost like the consistency of toothpaste. It's a really sticky, slimy, weird consistency. It's like, what's going on here? And that's a side effect of excess magnesium, extreme excess magnesium in certain types of soil structures and textures. And so in those soils, because the soil is decomposed rock, that's what soil is. If your rock is super, super high in magnesium, which serpentine is, what do you end up with? A soil that's filled with too much magnesium. So you have to work with that by adding extra calcium and potassium to overcome the magnesium problem, to get a balance back for your plants. So here's some magnesium deficiencies, and you can see here from this mosaic pattern how you could also look at this and say this might be a virus of some sort. When you get these patterns like this, that is something that you might think virus. Iron, it's not a part of chlorophyll, but it is required in a manufacturing step of chlorophyll. So to make chlorophyll, you need iron in the process. And so you can have something called iron chlorosis, iron deficiency chlorosis, because the iron is what's missing, not the nitrogen. And you can cause iron uptake to go down. Remember the issues of pH? Iron is not easily available. It doesn't dissolve well in pHs when the pH is high. So if I add a bunch of lime to raise the pH of my soil, if I raise it too much, or too much for my soil conditions, I might make iron unavailable to my plants. I raise the pH, and the iron is still there. It's just no longer soluble in the water, and the plant's not taking it up. So since the plant's not taking it up, what do I have? I have what's called lime-induced chlorosis. That's where there's enough iron in the soil, it's just not available to the plant because I added too much lime. And when I added too much lime, the pH went up, iron absorption, iron availability went down. My plants don't have access to enough iron to take up in the roots, and they can't manufacture chlorophyll anymore, at least not at the rate they need. And so your plants look like they're deficient in nitrogen. They look like it's a nitrogen deficiency, but it's not. It's an iron deficiency, either because there's not enough iron or the iron was made unavailable by raising the pH too much. Lime-induced chlorosis. And this happens a lot in calcareous soils. A huge part of Arizona is calcareous soils, and there's lots of California areas that are calcareous soils with pHs that might be in the 7, 8, 8.2 range. Very, very common, and you got to work on iron availability for your plants. It's something that you need to pay attention to in calcareous soils. Some plants more than others. So you can maybe use an acidifying fertilizer. There's certain iron mixtures where they acidify the iron as it's going into the water where plants can take up the iron that is needed. Bicarbonate is another base. Bicarbonate raises the pH, so when there's bicarbonate available, bicarbonate interferes with the uptake of iron, and it's even worse in waterlogged soils where you run out of oxygen. Zinc and boron and iron, the most common micronutrient issues. Lyme-induced chlorosis is the most common problem. And high pH soils, especially sandy soils, can also promote the iron deficiency. So again, we already talked about most of the things here. So here's Lyme-induced chlorosis. You can see a serious problem. Now, something that's different from Lyme-induced chlorosis to nitrogen deficiency is look at how it's not uniform. And that's very common in my experience as well, not just this photograph, but when I've seen Lyme-induced chlorosis in the field, it is not as uniform as a deficiency of nitrogen. It just looks different, as you can see in this photo. Next on the list is zinc. And zinc is involved in numerous metabolic functions, and it is a very important micronutrient. Plants don't need a lot, but what they do need, they need. It certainly is related to iron deficiency. They tend to go hand in hand, with sandy soils being a common scenario where you have deficiency of both. Sandy soils are deficient in damn near everything. That's just one of the traits of sandy soils. And when you get acid soils, zinc is available, but in pHs that are approaching neutral, approaching 7, or on the basic side, you have less availability of zinc. And zinc is one of those things that is a serious deficiency issue in Central Coast vineyard production. So you don't have to worry about memorizing the list of what it's used for, but it is essential in a number of functions in the plant. Deficiency, the variety plays a factor in what the deficiency looks like. Leaves become smaller in size. The veins of the leaves might look darker than the rest of the leaf. That's when you get it described as an interveinal chlorosis, where between the veins looks lighter, the veins look darker, and it depends on the variety. That interveinal chlorosis may be very mild, like it is in this photo, where I can see the veins look dark, but it doesn't especially look chlorotic in between either. Some varieties, the in-between looks more chlorotic. You can look up some pictures on Google and see what I'm talking about if you're interested. Internodes might be shortened, so your shoots don't grow to the length that they are supposed to. And in extreme conditions, you can actually have the apical meristem die. And you'll end up having the axillary buds start growing, making a bushier canopy, trying to compensate because your apical meristem died. And you're going to have an ugly canopy under those conditions. Shortened internodes, apical meristem dead, axillary buds starting to grow. It's a mess. In addition, fruit set is very important. Here's a zinc deficiency. I don't need to tell you that's a problem. You just take one look at that photo and that's a problem. So you get uneven ripening, reduced yield, serious problems that can really impact your ability to meet your profit and yield targets for a particular block. Boron, very tightly related to pH. So you need to be monitoring not only your soil boron levels, but also the pH and your tissue samples as well. Transpiration or water movement is helping also move nutrients, including boron. So you need a constant flow of water through the plants by a properly irrigated vineyard. And boron deficiencies are a widespread problem. It's one of the biggies listed for problems in grapes. And it's common in a lot of different permanent crops, especially. Not so much, we don't hear about boron deficiency as much in some of the short-lived leafy greens that are so popular in this region. But in permanent crops, orchards and vineyards, it's a much bigger deal that's discussed. It's easily leached from soils because of the form it takes, so it can move out. So if you're in the Pacific Northwest with high rainfall, there's another area that has boron problems. Acid soils, another problem. So if you're in a forested region, which, you know, in the peripheries of certain forested areas around parts of California, there are some vineyard areas, and those have problems. Failure of seed and fruit set, and that's the biggie. So here is a very ugly looking shoot. You get these fan-shaped leaves and shortened internodes. This is not good growth, but this is severe boron deficiency. Can you tell which of the grape clusters is deficient in boron? Not too hard to tell the difference, right? You want the one on the left, I think, right? And the one on the right is not going to make you happy, not going to make you money, not going to pay for the harvest crew to come through. Nobody's going to pay you for those grapes anyway. So fruit set is one of the biggest problems, and your clusters will not form properly. You're not going to get the fruit development because the seeds aren't developed. If you have a seedless berry, that's what you get on the right. Seedless berries don't develop. They're not pulling the nutrients to say, hey, grow a berry here. I got seeds. I was fertilized. Grow a berry. The hormonal signals aren't there because the seeds aren't there. No seeds, no signal for development, no cluster of fruit. So lots and lots and lots and lots of problems that can come from nutrient deficiencies or nutrient excesses. And I guess you can be fortunate or think of it in a fortunate way that what did he have on his list? I think it was 8 on his list of the most important deficiencies, things to monitor in Central Coast vineyards. Out of the 7, or excuse me, out of the 14, the CHO, nobody monitors CHO because it's not nutrient elements. It comes directly from water, directly from carbon dioxide in the air, directly from oxygen. So that's it for nutrients. Fine nutrition.